Well, we've basically come full circle as we start end of year final review part 3. This is taking us back to quarter 1, what we did at the very beginning of the year, putting it all together. So again, I'm going to work through these problems. Hopefully you've already been through them and that you have all those cobwebs out and are remembering what each of the vocabulary terms mean, as well as how to simplify all of these different kinds of expressions. So let's just work through this. I'm going to do this video in 2 parts. The first part will work all the way up through our factoring pieces, and then I will create a new one related to the factoring problems. So, to start with, just some vocabulary. Number 1 says, for the polynomial given, write the expression in standard form. Then, state the leading coefficient, the degree, and classify, or in other words, name the polynomial by its number of terms. So let's start here with standard form. Again, if we're writing a polynomial in standard form, right, remember that standard form means that the exponents start with the highest exponent term and then they decrease as we move to the right. So if you look over here, this is the highest exponent in this expression. So this term right here gets to be the first term, right? So we move negative 9n cubed. That's the first term. Then we look for the next highest exponent. Looks like it's squared, so this 2n squared gets to go next. So we say plus 2n squared, and we use a plus sign because it's positive. And that leaves us lastly with negative 3n, bringing up the rear there. So remember, those signs stick to the terms that they're with. The next part is asking us to state the degree of, the leading coefficient. The leading coefficient is the coefficient in the front of the expression, right, when it's in standard form. So again, if we look right here, coefficient means the number out front of the variable. So negative 9 is the coefficient that is leading this expression. So we would say negative 9. Okay, again, that's when it's in standard form. Next, it wants us to identify the degree. So remember, the degree is the highest exponent. So if you put it in standard form, it's that first exponent, or again, you just look at your whole expression and it's going to be the highest exponent. So this has a degree of 3. Then lastly, it wanted us to classify it based on the number of terms. So if we look over here, right, it had 1, 2, 3 terms total, which makes it a trinomial. So remember, 1 term is monomial, 2 terms binomial. This one has 3, so we call it a trinomial. Okay, vocabulary. Number 2, simplify the radicals. So you guys were great with this, with breaking down the tree, or breaking down each piece. I'm just going to do number 3. Again, if you found a negative inside and it was a square root, we knew that that negative had to come out as the imaginary number I. So this one would look something like, for I, square root of 75x squared y to the 4th. Once we've taken care of that negative, we just simplify it with a factor tree. So we break down 75. Now something that multiplies to 75, well, it ends in a 5, so it's probably divisible by 5. So if we divide that by 5, we end up with 5 and 15. We keep dividing 15, so 5 and 3. Notice you have a group of 5s there. And remember, when you have a group, it comes out and multiplies by the coefficient out front. So one of the 5s gets to come out, multiplies by that 4. That leaves us with 20. We still have that I there, and I haven't forgotten about the 3. We already broke down the 15. Let's look at our variables. So we've got 2 x's there, that makes a group. We've got 4 y's, that makes a group, and another group. So we're going to bring out an x for that group of x's, and there's 2 y's, so we're going to have y squared. And then remember, we put anything not in a group back in. So the only thing that doesn't have a group, it looks like, is that 3 right there. So we put the 3 back in, and we've simplified that radical. Okay. All right, moving down, perform the indicated operation to write each expression in simplest form. So your goal here is to either multiply, add, subtract, whatever you need to do to simplify the expression. Again, remember that we always look here and we see what's happening kind of between these binomials. That one's multiplication. Notice down here, if we look at this one, there's a subtraction sign. So this one you're just subtracting terms. Here, this one's addition. So we're always looking between. This one again would be multiplication. So identify that first, making sure that we perform the right operation. Okay, on this first one, it looks like we just need to FOIL. There's two binomials, so we multiply first times first. 6n times 3n is 18n squared. Don't forget that squared. Then we go 6n times negative 7, and we get negative 42n. Again, we're just distributing. Once you distribute the 6n, you need to distribute the 2 to each piece over here. So 2 times 3n gives us 6n. 2 times negative 7 is negative 14. Okay. Once we've multiplied that, we just combine like terms. Notice these two in the middle are like terms, so I'm going to have my 18n squared still. If I take negative 42 and I add 6, that gives me negative 36n minus 14. So this would be simplified. Notice it's in standard form, and there are no more like terms, so we've combined that. Number 5 is very similar. However, you need to remember that when we have something that looks like raised to this second power, that means there are 2 of those. So we talked about over and over, you cannot just multiply this inside and square each piece. Doesn't work like that. That means that there are 2 of these. So 7 plus 8i and 7 plus 8i that are multiplying by each other. Again, once you have those there, you can go ahead and FOIL that. So you're going to multiply there, you're going to multiply there, multiply there, multiply there, and then combine like pieces. Now I'm going to work this one out. This one has i's involved, so notice we go 7 times 7 to start with. Gives us 49. Then we distribute 7 times 8i. Well, 7 times 8 is 56, and there's an I there, so we're going to put an I with it. We then distribute the 8i to the 7. Again, 8 times 7 is 56, and there's an I. And then you have 8i times 8i, which is 64i squared. Now remember, we talked about I squared is equal to negative 1. So anytime we see an I squared, that's equal to negative 1. So this last term here is really 64 times negative 1, and we can simplify that I squared so that it just goes away. So really what we're looking at here is we've got 49. I'm going to combine these two middle ones because they both have an I. They're like terms. So 56 plus 56 gives me 112i. And then here, 64 times negative 1, I have minus 64 there on the end. Notice then you have like terms here. So 49 and negative 64, those are both real numbers, right? There's no imaginary unit with them. So we go ahead and combine those. So 49 minus 64 is negative 15. And then we still have that 112i. So again, just combining the like pieces once you've done that multiplication. All right, number 6, again, just a reminder, this one is subtraction. So we're always looking right there to start with. This is subtraction, which just means that basically there's like a negative 1 there that needs to distribute to each of these pieces right behind it. So this is the same thing as 7n minus 6n to the 4th. If you distribute that negative 1, that's like negative 4n to the 4th. And negative, oop, that doesn't look like a 4, sorry. And negative 2n. Okay, and then it's just a matter of combining like terms. So you've got a negative 6n to the 4th and a negative 4n to the 4th. So negative 6 minus 4, that would give me negative 10n to the 4th. And then you've got 7n here and negative 2n here. So 7 minus 2n is a positive 5n. Okay, just combining like terms. Number 7. So again, this one we look between and it's multiplication. So it looks like we're going to have to FOIL this. So you just need to keep track of those radical pieces. So we've got the square root of 3 times the square root of 3. So we multiply the insides of the radical, and that just gives us the square root of 9. When we multiply the square root of 3 by the square root of 5, again we just multiply those insides and we get the square root of 15. Then we start to distribute this term right here. So this term times the square root of 3. Now notice there's a 4 out front of the radical square root 5. There's not anything out front of the square root of 3. We can imagine there's like a 1 there. So the 4 out front times the 1, right? We're just leaving a 4 out front there. So we're going to put, lost my color, plus 4, and then we multiply the insides. 5 times 3 is 15. And then lastly, we multiply this term by the last piece. So again, it's like there's a 1 out front of here, so this one's just going to be 4, and then 5 times 5 is square root of 25 on the inside. Okay. Again, once you FOIL that, you're just simplifying if you can. So simplifying radicals, remember we can only add or combine like radicals. That makes them like terms. So this one right here, right, square root of 9 is just 3. So that's a 3. Plus, you've got 1 square root 15 here, and you've got 4 more of the square root 15 here. So those are like radicals. We can combine those. So if I have 4 and I add 1 more, I have 5 square root of 15. And then lastly here on the end, right, 25 is 5 times 5, so that gets pulled out. So 4 times 5, that's just going to be 20 on the end there. So again, it looks like we have a like term. We have this 3 and we have this 20 that don't have radicals. So we can add those two together and get to, okay, 23 plus that 5 square root of 15. That's left there. Okay, so distributing, making sure we're comfortable multiplying those radicals once again, and combining like pieces. All right, moving down, number 8. So 2n plus 4 plus 5n plus 5n squared minus 6. Now again, this one is addition. So don't start distributing on this one. You're just finding like terms. I always find the one with the highest exponent first. So if I look at this one, 5n squared, there's not another n squared term, so he just gets to hang out by himself in the front. Then we're looking at the next one, which is just our n's. So we've got a 2n and a 5n. So 2 plus 5, that gives me 7 n's. And it looks like we then have a 4 and a negative 6, which combine to give us negative 2. Okay. Again, these next ones are very similar. So number 10 is very much like number 5. You're just going to distribute and FOIL that. And there's an I squared there, so make sure that you're taking care of that I squared. So I'm going to skip over that one. I want to look at number 9 though. There's a 3 out front. So there's 2 ways you can do this one. One, you can start by distributing the 3 first. Remember, the 3 doesn't go to everything, or you've double distributed. You just distribute it in here, and then you can FOIL what's left. So we're going here and we do 3 times 4x. Well, that gives me 12x. Then I do 3 times negative 3. That's negative 9. And then I bring down the 4x plus 3. Right, so that's what we're looking at there. Then we go ahead and FOIL. So 12x times 4x, that's going to be 48x squared. 12x times 3 is a positive 36x. Negative 9 times 4x is negative 36x. And negative 9 times 3 is negative 27. Notice there in the middle you've got a positive 36x and a negative 36x. So those two are going to add to 0. That just leaves you with 48x squared minus 27. Okay, so again, simplifying those out. And then lastly, you have a radical here, multiplying them together. Again, so you're taking this term, multiply here, taking this one, multiplying here. So just distributing. Again, there's a negative 3 out front of here, so we treat it like there's a 1 there. So we would get negative 3 and then square root of, and we multiply the radicands, so 10 times 2, which is 30. Then we distribute again this piece to this piece. So we multiply the negative 3 out front by that 3, and we get negative 9. And then on the inside we've got 15 times 3, which is 45. Now again, you're almost done. Once you've done that multiplication, just make sure you can't simplify. Remember, 30 is like 3 times 10, which is 2 times 5. There are no groups in 30, so it doesn't simplify. But 45 would be 9 and 5 and 3 and 3, so there is a group there. of 3's, so that 3 will come out and multiply. So this guy will stay the same out front, so we're just going to have negative 3 square root of 30. But then in the second term, we're going to pull that 3 out and multiply it by the negative 9, so we get negative 27. And it looks like the 5 is the only thing left that wasn't in a group. So we're looking at something like that. Okay. All right, a couple more on this video. Number 14. This one, notice, is just addition, subtraction. There's lots going on, it looks like there. But again, notice that's just addition. And this one is subtraction. So again, that's like a negative 1 that we need to take care of that negative. Don't lose that negative. So this is like negative 3i plus I. Then we distribute that. That negative 1 times negative 7 is like plus 7. And negative 1 times negative 7i is like plus 7i. So really, by distributing that negative, we're just looking at something like this. Then we're just looking for like terms. So here's our negative 3i plus another I, so that's like 1i, right? Plus 7i. There's all of our I terms. So if we add all of those i's together, we end up with 5i. And then we've got this positive 7 here, so it's like 7 plus 5i. And again, if you have the TI-84 calculator, remember it does all of these I problems. The I is the decimal button. You just have to push second decimal in order to access the I. So you can always check your answers with the imaginary number problems. Number 15, again, you can do your calculator on this one too. You just have to remember to put parentheses around the numerator and denominator. On this one, this is the one where we use the conjugate. So our goal is, when we divide complex numbers, is just to get the I out of the bottom of the fraction. So if I want to get rid of that, we multiply it by the conjugate. Now remember, the conjugate is an identical binomial as the denominator, but opposite sign. So if it's a negative 10i in the original, we're going to put plus 10i when we multiply it. And whatever we multiply the bottom by, we also multiply the top. Okay, so again, this is just like two multiplication problems. So we're going to distribute the 8. 8 times 4 is 32. 8 times 10i, 80i, all over. And then we're going to FOIL this. So we've got 4 times 4, which is 16. 4 times 10i is 40i. Negative 10 times 4 is negative 40i. And negative 10i times 10i is negative 100i squared. Now again, if you look at the bottom, the 40i and the negative 40i are going to add to 0. They're going to cancel out, right? That's why we use the conjugate, because it made that happen. The other piece we can simplify is, notice this I squared. Remember, from the front, I squared is equal to negative 1. So if we multiply this negative 100 by negative 1, really all that's doing is making it a positive value. So on the bottom here, if I were to rewrite this, I'm going to leave the top the same. I now have 16 plus this 100 right there. Right? So this is really like 32 plus 80i over 116. Now, you can leave it in that form. Generally, we would simplify it. So if you notice, all of those are divisible by 4. See if they're divisible by 4. Let me handy dandy check. Yeah, so if we take these 3 coefficients and we divide all of them by 4, then we end up with 8 plus 20i all over 29. So we just divide that. And then you can leave it in that form. If we wanted to write it in standard form, sometimes we'll just put the 29 under each piece. So it would be like 8 over 29 plus 20 over 29i. And again, we write it in that form generally only for graphing complex numbers. All right, last two on this video. Number 16 and number 17, factor by grouping. Remember, when there are 4 terms, there is no common factor that divides out of this term, this term, this term, and this term. So instead, we group them together. So we're starting here with these first 2, we'll group them, and then we'll go ahead and group these 2. So what we're doing is looking for a greatest common factor. So we've got 2k cubed minus 6k squared. Well, the only thing common there, they're both divisible by 2. And then notice that both terms have at least two k's. So we put k squared and divide that out. Then if we look at this second group, if we're looking at something that divides out of that, both of those terms are divisible by 5. And we talked about in class, if there's a negative leading the group, we're going to pull out that negative with that greatest common factor. Okay, then it's a matter of just dividing this out. So we take what we pulled out, put it out front, and then we divide it out of each term. So if you divide the 2k squared out of this term, right, those 2's go away. You have a k cubed up here. You cancel 2 of them, and that only leaves 1k left there. And then again, we do the same thing here. So negative 6 divided by 2 is negative 3, and then both of those k squareds cancel when you divide that. Okay, we're done with group number 1. We move to group number 2. Again, you have a negative 5 that you are dividing out or pulling out front. If you divide that in the first term, that negative 5 divides away, and we just have k. And then here we have 15 divided by negative 5, which is negative 3. Now when we factor by grouping, a reminder, this is what we're looking for. Notice you have the same thing in there. That means that's the new greatest common factor. So what we do is we write k minus 3 out front, and then the leftover goes in the second one. So 2k squared minus 5. This guy right here, if we were to FOIL that, would give us that original polynomial. Okay, number 17 is very similar. Again, you just need to be aware that sometimes 1 is the greatest common factor. So if we look at this first piece, nothing divides out of that except for x squared. And if you look at this second piece, nothing divides out of that except a positive 1, which seems weird, but it's going to relate to our final answer. So if we pull that x squared out again, notice here it's going to leave 7 and it'll leave an x. X squared divided by x squared, anything divided by itself is 1. Okay, then in this one, the second group, right, we put this 1 out front because it's what we're taking out. And just leave 7x plus 1 in here. So notice once again you have 7x plus 1 and 7x plus 1. If that's common, then that can come out front. It's the greatest common factor. And then we put the leftover in the last parenthesis. Okay, so that's it for factor by grouping.